Okay. So, let's go to, now, y'all, time is ticking. It feels like forever since I have seen you. I know it probably doesn't seem like that for y'all, but it does for me. Look at all this time that has ticked away. After today, I only see you 1, 2, 3, 4, 5 more times. We're down to one hand. That's it.
Oh, thank you for break.
Yeah. So we have a full week next week, and then we only come a day. Y'all, 2 weeks, not next week, but the next week is Thanksgiving. We are ticking away. So we have a full week, and then we have half a week, and then we have a full week, and we're done. That's it. So we have 5 days left. And then you have your final exam. So, now what I have decided, and I had this thought in the car coming over here, is if you get your schedule done, your 2019 spring schedule, that's supposed to be done before Thanksgiving, and show Cooper
Actually, you might have.
Me too. Yeah, I'm about to go, I'll have my Monday.
I'll add 8 points to your lowest test grade.
Amen.
Okay, so just stop and see me after class, show me your schedule. It can be on your phone, it can be a piece of paper, whatever. Just to show me that you've gotten out there, done your schedule for spring, and I will add 8 points to your lowest test score. We good?
I need that as for probability. Me too.
Okay. And it really doesn't matter if it's to the, because y'all, when I get your average, I add up all the tests and divide by how many tests you have. So whether I did it on a past test or a previous test, it's still going to be added up there together. Y'all with me? So it doesn't matter if I do it on the one in the future or the one in the past, it's still going to get added up. We good? All right, so threw that out there. Now, when we, and that was, what did I just do? Did I have a moment? I think I had a moment that I did not clean up your notes. Let me do that real quick. Cut. Okay, so when we left last time, we were talking about, I'm gonna leave it right here. Let's do, oops, right here. Let's do select all, and let me do paste. Okay, when we left last time, we were talking about whether the scatter plots were uphill, which is positive, whether they were downhill, which is negative, whether they're close together, which is strong, whether they were kind of far apart, which is moderate, or whether they were way apart, which is weak. That's what we were talking about at the very end of class last time. Then, we kind of started talking about, and let me open up the computer for anybody that needs it. I just opened it up if you need to pull your computer up. Let me see. Does anybody have any data in their stat edit? Let me pull up a problem and see. Oh, y'all, at the bottom of your notes, I accidentally left in your notes from last class period, I accidentally left the marijuana problem from the test worked out, accidentally in your notes, left the test actual question with different problems, accidentally worked out in your notes. Just saying, it just, yeah, it accidentally left in there somehow, don't know. Huh?
The goat.
Yeah, the goat, I'm a goat. MJ,
You're a cool goat.
I know MJ said he wasn't going to be here today, and so he sent me a text saying, can you record class? And I said, yeah. And then you wrote me back and said, you're the goat. With like 100 with the exclamation point. I'm like, he called me a goat, y'all. And it says greatest of all time is what goat means. I'm like, oh, that's a good thing. Goat. So I'm going to go home and tell my 12-year-old I'm a goat. Okay, so when we stopped last time, we were going to talk about what the R value was. Okay, now R value, and I'm going to show you how to find it in the calculator, but R value is how strong the line is. And R value is a value that goes from -1 to +1. Okay? Now, the closer it is to the 1 values, the stronger it is. The closer it is to the 0 values, the weaker it is. And if it's in the middle, we call it moderate. So, the closer you are to $1, the stronger you are. Whether it's a positive dollar or a negative dollar, the stronger you are. The closer you are to being broke, it's a weak. And if you're around 50 cents, we call it moderate. So these are the R values. Now, they're going to be a little bit different according to how many pieces of data you have. So we have a little table over here that's going to help us with a lot of these problems. And I'm going to talk about this table in just a minute. So the closer to $1, the stronger you are. The closer to 0, the weaker you are. And the closer you are to the middle, which is like 50 cents, 40 to 50 cents, it's moderate. And if I come back up, and I'll come down in just a second, but if you look right here, see how these R values are $1? That means they're strong. That means they're linear. These are kind of moderate. And look at their R values. These are weak because they're closer to being no money. Okay? Now, I'm going to show you that table in just a minute. We're going to go through a problem, kind of like what we did last time on that blue sheet. We are comparing how much a car weighs and its miles per gallon. So we're going to pull out our calculator, and together we're going to go through that whole process again. I know it's been over a week, so we're going to kind of walk through it again. So on here, on that blue sheet, does anybody in here not have the blue sheet? Okay, blue sheet. And you're not going to have this blue sheet on the test. Okay? So on this blue sheet, it kind of goes over those steps. Remember, these are the titles of what we need to do. Now, remember that this is the same thing as going program, fix calc. So if you've already done that on your calculator, you don't need to do it again. You do program, fix calc, enter, enter. Are we good? So now we need to do our Germex steps. Our Germex steps are going to be y equals, make sure your plot 1 is black, and make sure all of these are clean. We good? That's step 1 and step 2, that your plot is black and all of these are equal, or 0, or nothing. Then you're going to do second quit, second in the button beside it, and that just gets you out of there. Second quit, that just gets you out of there. And if you have anything on your home screen, you might as well clean that too. And then next you're going to do second catalog, or second 0, and you're going to hit the button with the C on it, and then you're going to scroll down to clear table. So second catalog, hit the button with the C on it, and then scroll down to clear table. Once you get beside clear table, you're going to hit enter, enter. And finally, you're going to do stat, edit, and then we're ready to type in our data. So that's our Germex steps. So our data is going to be, this is our L1, otherwise known as X, and this is our L2, otherwise known as Y. So just like we did before, we're gonna go to the top, hit clear enter, and then we're gonna go to the other top, hit clear enter, and we're gonna type in our data. Make sure you enter the data correctly. And if you mis-enter one, it doesn't matter the order, but you have to have these two numbers paired together. So if you accidentally miss that one and put it at the end, that 31's got to go beside it. So the first things I did is my Germex. The second thing I did is stat edit, and I did my L1 and my L2. We good? And I'm going through everything that this blue paper says. So, Germex, enter the data. Now, it's like we're going on a date, we cleaned ourselves, we got dressed, and now we're gonna look at me. What do we do on our calculator to look at me? Zoom 9. So on my calculator, I'm gonna do Zoom 9. Zoom is the middle up underneath my on my screen, Zoom number 9. Okay, if yours does not look like that, then you need to let me know so we can fix your calculator. Zoom 9. Okay, now when you go to your y equals, that plot right there needs to be black. So you go up on top of it, hit enter, and come down. And it'll stay black the whole time. You don't have to go up there and do anything. You just glance to make sure it's black. Okay, now for you, you're gonna go into your stat plot. And you have it on that. So go down, right there, and hit enter. And now do second clip, and do zoom 9. You had it in histogram mode instead of hold on, let me hit the lock button. Alright, is he, okay, I'm coming. See? Okay, hit your, let's go y equals. That plot one right there needs to be black. You get on top of it and you hit enter and come down. So now hit zoom 9. Okay, now you're in histogram mode. So let's go to here. We've got histogram checked, and we want that one checked. So let's do zoom 9. There we go. Is everybody good? Okay, so we've done Germex, we've done entering the data, and we've done look at it. So question 1 says stat plot. This is what they want. They want the stat plot. Now, what kind of correlation is this? Positive or negative?
Negative.
Negative because it's going downhill. And it looks like it's a good relationship. It looks like it's linear, correct? Okay. Now, our next step, which we didn't do much of last time, our next step is the work it out. We've gotten dressed, we've cleaned up, gotten dressed, we've looked at me, now we're going to work it out. The work it out is the stat count part. Okay? So in our calculator, we're going to do stat over to calculate. Now, up until now, we've been doing 1-bar stats. That was our mean, median, mode. We're now doing the one that's called linear regression. Okay? So we're going to go down to number 4, or either you can hit number 4. And it's going to look like this. It's going to say L1, L2, empty, empty, empty. Let me move these down. Let me grab all of these.
If you don't have that, you just enter.
It just hit enter, enter, enter. All right. And then enter, 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 enter. And this is what you should have. Is that what y'all see? Are we good?
No.
Did you get it?
It's the last line.
Okay, you don't have the 2 R's? Did you do that program, fixed calc program? Have I put that on your calculator? You did? I did? Okay, do program, hit the program button, and do enter. One time. Okay, now do stat calc. Yeah, there you go. Are you good?
Yeah, I got it.
Okay. Yeah, that, okay, yours probably goes out a little bit, but, okay, her numbers are a little bit different at the end than mine. In my math lab, they're only gonna want you to round in 3 or 4 places. So our first 3 or 4 places are fine. My calculator may have extra spots or a little bit less spots, so we're good.
Are you always gonna need to do program fixed calc before you do
Yes. And as long as you do it, because you know you're not gonna be using your calculator on the test, the calculators over there have fixed calc. So as soon as you go to start this test, because this is the only test that it matters with, and the final exam, you will do fixed calc. When you start the test, you don't have to do it before every test. But fixed calc gives you these 2 things. That's one of the things it does, is gives you these 2 things. And if you don't do fixed calc, you're not gonna get those things right there. That's one of the things that it does. All right, so let me tell you a couple of things about what I just did. So we did stat, calc, not one bar stats, we did stat, calc, linear regression. Now, what this is telling me is that's telling me the equation of the line that goes through here. So if I were to draw a line that represents all those points, this is the line that goes through those points. That's what your calculator just did. It just said, hey, you got a bunch of points, let me try to draw the line of best fit. So it's like looking in the sky and seeing a bunch of dots or a bunch of stars and saying, if I had to draw a line through those stars, where would it be? That's what your calculator just did, okay? And your calculator came up with an equation for that. Back in the old days, in the 1900s, as my daughter used to tell me when I went to school, I had to do this by hand. So, here's what your calculator did. It says, okay, the equation is y equals ax plus b, and this is the value of a, and this is the value of b. So the equation of that line is going to be y equals negative 0.00754 blah 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 x plus 55.43855 blah blah blah. So that is the equation of that line. That's what your calculator just said. Cool? Now, the r value is negative 0.9868 blah blah blah. That tells us how strong the relationship is. Now, this may be a good line or this may be a crappy line. And the way that we tell if it's a good line or a crappy line is we look at this little table right here. And I'll provide this table for you. First, you have to say how many data points were given to you in the problem. So, if I come back up here, we were given 1, 2, 3, 4, 5, 6, 7 data points. We good? So if I come down here, we were given 7 pairs of data. So this is what we call our critical value. So if my R is bigger than this R, then this is a good equation. It's linear. If my R is less than this, then it's not a good equation. And we don't look at the positives and negatives, we just look at the number. Okay? So, and we call that the absolute value. So if the absolute value of my R is greater than the critical value, then it is a good linear equation. So my R is 0.9868 if I take the absolute value of it. Their R is 0.754. So is my R bigger? Is 98 cents bigger than 75 cents? So this is a good linear equation.
But why we choosing 0.754?
Okay.
Just compare.
We're looking at that one because if I come up here, I have 1, 2, 3, 4, 5, 6, 7 pieces of data. And in this chart, if you have 7 pieces of data, this is what you use. If you have 4 pieces of data, this is what you would use. So the more data you have, the stricter you have to be on your R.
And this table is.
Going to be given to you.
Okay.
Yes. Yes,
Now,
ma'am.
If you didn't want to do it by hand, which one of those would be the X value and which one would be the Y? Or do you have to do that by hand? That part?
This part, they will, on the problems, they're not going to ask you every one of these every time. They may just say in the homework, give me the scatter plot and that's it. So if they just say in the homework, give me the scatter plot and that's it, then you're going to Germ-X, get dressed, and look at me. And be done. This is if they say, is it a good linear relationship? You would have to Germ-X, you would have to put in your data, you would have to zoom 9 it, then you would have to stack calc and look at your R value and compare it to the critical value and say, yes, it's a good linear relationship. So every problem is going to stop at a different part. We're going to do several of these, I promise. Now, let me see if I got to go further on this one. Like this one, it says, is there a linear correlation? Is there a linear relationship between the two things? And we would say yes, because my R value is greater than the critical value. Because my R is bigger than the critical value. Yay? Let me let you try one. And we haven't done a full problem yet. I'm easing you into them. Okay, I gave you a bunch of data. We are comparing shoe print lengths and heights to find the best predicted male who has a shoe print length. And y'all, this is what they use in CSI and stuff. You know, if they find a shoe print, they need to know how tall the person is. So this is somebody's shoe print, how long their foot is and how tall they are of a bunch of people. So if we find a shoe print of 31, we want to know to help police people to describe the male. So, what are the two things that we are comparing? Shoe print and heights. So shoe print and heights is what we're comparing. They gave us that and they didn't even ask us to look at it. That's extra data that we didn't need. We good?
I was gonna ask you which one.
Which ones do we need? Yeah, we don't have an L3. We're just looking at 2 sets of data.
So there is some question with L3.
We're not going to be using L3 ever. Yeah. They threw something in to confuse you and it's working.
Okay.
Okay? So, the first thing we do is we Germ-X. So pull out your calculators and let's start Germ-Xing. Where do we go to Germ-X? Where's the first place we go to Germ-X?
Y.
Y equals. And when we go to Y equals, we have to make sure that the plot one is black and there's nothing here. And we haven't gotten there yet, y'all. We haven't gotten that far on the date yet. Your stuff hasn't been messed with yet. That's steps 1 and 2 of Germ-X. What's step 3 of Germ-X? Second quit. That just gets you out of there. What's step 4 of Germ-X?
Second cat.
Second catalog. We want to go to clear table. Second catalog, clear table. You get beside it and you hit enter, enter. And finally, we want to do stat edit. Go to the top, clear enter, go to the top, clear enter. We have cleaned our cell from top to bottom. Now we are ready to put in our data. So type in your L1, type in your L2. I moved it on you. So first I did Germix. Second I did stat edit. Oop. So we cleaned ourselves and we put in the data. So third, I'm gonna look at me. I'm gonna do that zoom 9. I'm gonna come over here and I'm gonna do zoom 9. And that just lets me know what I look like in the mirror. Am I very linear? Not really, okay? So if I had to draw a line, my line is not gonna be pretty much on those points. So it's not looking very good. So now I've looked at me, now I need to work it out. How do I work it out? Stat calc, you want to calculate it, you want to work it out. So we're going to do stat calc, stat, calculate, linear regression. Number 4, stat calc, linear regression. Stat calc, linear regression.
The R's not coming up on these.
Okay, for that one, go to, for the one on the computer to get your R, you've got to do, second catalog, and go to diagnostic own. So go to your D's and get beside diagnostic own and hit enter, enter. That'll get your R value. That's made into the fixed calc program, but those computers don't have fixed calc on it.
What's R squared? You just square your.
You square your R value, and I'll show you what that means in just a second. This book doesn't talk about it much, but I'll show you what that means. It's super easy. Fourth, we did stat, calc, linear regression. So this is my R value, and this told me that my equation is y equals 1.727x plus 125.407. So that's the equation of the line through those points. So this equation is the line that's going to go through those points. Now, my R value is 0.5913. To figure out if this is a good equation, I've got to figure out which critical value do I look at. So I come up here and I say, how many data points do I have? 1, 2, 3, 4, 5 data points. So I come down here and I say I have 5 data points. So this is going to be the critical value that I'm comparing it to. So I'm comparing 5913, which is mine, to 0.878, which is theirs. I want mine to be the biggest one. Is mine the biggest one?
Not a good linear.
So this is not a good linear equation, because mine is not the bigger one. And we can kind of tell it from the picture too that it wasn't pretty. Good? Are we feeling a little better about those?
I like it better.
Now, just to show you what the R squared means, the R squared is exactly what you said, Ann. The R squared is when we take the R value, the 5913, and we square it, and that gives me 0.349599. And if you whoop that, 34.9%, so that means this equation works 34.9% of the time, which is telling me that this equation pretty much sucks. So if I had to use this equation for my business and it only worked 35% of the time, I wouldn't use it. That's what that R squared means. Now, this tells me how do I match up the equation with the picture? Because we've now